Okay, May, June 2024, paper 6, variant 2. Question 1. A student measures the spring constant K by two different methods. Okay, method 1, he attaches the spring to a clamp as shown. The mass oscillates up and down. Okay, keeps on oscillating up and down as he pulls it. Record the time t in the table. Can I record this time in the table? Yes, it is 17.76. Should I write it down as 17.76 or 17.8? Definitely 17.8 would be a lot more accurate. 17.8 would be a lot more accurate. And then can I find the period or capital T? Yes, I can find the period for one oscillation. One oscillation. How many oscillations were they? They were 20 oscillations. So 17.76 or 17.8 divided by 20 would be around 0.888, or you can just write it down as 0.89. 0.89. Suggest how the procedure can be improved to increase the accuracy of the result. How can I increase the accuracy of the result? Think about it. Increasing the accuracy of the result. Can I increase the... Yes, you can increase the number of oscillations. Okay, increase the number of oscillations. Increase number of oscillations. Now, calculate the value K1 of the spring constant. Okay, K1 would be 19.7 over T squared. 19.7 over 19.7. This is 19, not 1.97. 19.7 over T squared, which is 0.89 squared. 0.89 squared. What is 19.7? Over 0.89 squared. This would be around 28.7 or 20. So I'm sorry, 24.87, which is 24.9. Okay, 24.9. Okay, not bad. The student measures the stretched length with 500 grams. Okay, and then we need to measure. This is the full size. Okay, actually, this is 1/4 full size. This is 1/4 full size. So this is the spring. Can I measure length L using the ruler? Yes, I can measure the length L using the ruler to measure this distance. Can I find this distance? Yes, I can find the distance. It would be around maybe 5.6. If you printed out the paper, it might be slightly less. Okay, might be slightly less than 5.6. If your answer is 5.5, again, that is acceptable. So 5.6 centimeters. Calculate the actual stretched length. Can I find the actual stretched length? Yes. What would it be? It would be 5.6 multiplied by 4 times a 4, or you can divide by 1 over 4, which is the same. So 5.6 times 4. What is 5.6 times 4? It would be 22.4. 22.4. I need to record the length in the table. 22.4. Okay. Student removes the 100 gram masses, keeps on adding, okay, or keeps on removing the 100 gram masses. Plot the graph. Start your axes, and this time the graph is out of 3 only. Why? Because he already wrote down the axes. He already wrote down length slash centimeters and m/grams. So you only need 3 marks. The length started with 6.1, ended with 22.5, 22.4. So you can write down 5, 10, yeah, 5, 10, 15, 20, 25. On the x-axis, 100, 200, 300, 400, and 500. Yeah, this is easy. At 100, the length was 6.1, and then 10, 6.1. Let me zoom in a bit. So at 100 it was 6.1. This is 6. And then at 200 it was 10. At 300, 18.3, 14.3, 18.3. Okay, so 14.3 is here. Then 18.3 is right over here. And then last but not least, 22.4. It almost increases by 4 each time, right? Almost increases by 4. 22.4, which is right over here. This is a almost very accurate graph. Can I draw the line? Yes, I can draw the line, and this line would actually pass through all of the points. Let's draw the line. It should pass through all of the points. And if you were quite accurate, it should reach exactly 2. It should reach 2 on the y-axis. Okay. Show all the working. Can I find the gradient? Yes, I can find the gradient. y2 minus y1 over x2 minus x1. Again, you need to take 2 points from the graph. I usually take the 2 furthest points away. You cannot take 2 very close points. You need to take the 2 furthest points. So I'll take this point along with this point, and you have to draw the triangle method. If you do not draw the triangle method, you will lose a mark. This is the triangle method, which is basically rise over run. Again, y2 minus y1, but he needs to see it on your graph. He must see it on your graph. So y2 minus y1 over x2 minus x1, the points would be around 22.4 minus 22.4 minus 6 point, what was it? 6.1 over the, hmm, which would be around 0.04. 0.04. Let me remove this line. Okay. This would be 0.04. Again, how did I find it? 22.4 minus 6.1. 500 minus 100. Now he needs me to find K2, which is 1 over G. Okay, K2, 1 over G, so 1 over 0.04, which is 25. Which is 25. Two quantities can be considered to be equal if they are within the limits of experimental accuracy, or if they are within 10% of each other. Compare your values of K1 and K2 and state whether they are equal or not. K1, K2 is 25, K1 is... where's K1? 24.9. Are they equal? Yes, they definitely are equal if you divide the larger number by the smaller number, which is 25 over 24.9. This would be, what's 25 divided by 24.9? A very small difference. We're talking about a 0.4 difference. You can multiply it by 100. Okay, if you multiply it by 100, this would be 104. So 100.4, which is only 0.4 difference. 0.4 difference. Definitely, they are the same value. 100% they are the same value. Okay. Okay. So yes, and the same value. Values are close. Okay. Numbers are close and within the limits of experimental accuracy. Within limits of experimental accuracy. Okay, not bad. Now we have a resistance. We need to investigate the resistance of the diode. Can I find the resistance of the diode? Okay. Student closes the switch, records the voltmeter, and opens the switch. We have the voltmeter. What was the reading on the voltmeter? 0.6, 0.7, 0.8, 0.84. It was 0.84. And the current was 0.1236. 0.36. So the voltage was 0.84. 0.84, and the current was 0.36. Can I find the resistance? Okay. R equals V over I. So 0.84 over 0.36, which is 2.3. Yes, the resistance was 2.3 ohms. Can I find the second resistance? Okay, can I complete the table? Yes, to find the second resistance, 0.83 divided by 0.27, which is 3.07 or 3.1. 3.07, I know it's 3.07, but write it down as 3.1. Why should I write it down as 3.1? Because they are only two significant figures. And then, can I find the current? Can I find the current? Yes, I equals V over R. I equals V over R. So 0.81 divided by 4.5, which should be around 0.18. 0.18 amperes. Okay, student connects a 3 ohm resistor in series with the 10 ohm resistor between X and Y. Then he connects another 7 ohm resistor in series with them. Okay, we completed the table. As the resistance between the terminals X and Y is increased, the current in the circuit changes. Current in the circuit changes. Use the results from table 2.1 to state the relationship between the current in the circuit and the potential difference across the diode. Let's check the current. As the current is now decreasing, and the potential difference across the diode is what? It's almost constant, isn't it? Potential difference is almost constant. It doesn't change that much, 0.84, 0.81. It doesn't change that much. So the current decreases, but the potential difference is the same. So the current decreases, but the potential difference is constant, right? Okay. The resistance of the diode. So let's check the resistance. As the current decreases, the resistance is actually increases. The resistance is actually increasing. So as the current decreases, the resistance increases. A student attempts to set up the circuit shown. Another student, not the same one. He attempts to set up the circuit. As shown, the student finds that the ammeter does not give a reading when the circuit is complete. The ammeter is not broken. To be honest, the ammeter is not broken. Suggest what the student may have done incorrectly. So another student is trying to set up the circuit, the same circuit. He has the diode, he has the resistors, he has everything. He has the other resistors. What could be the problem, okay, while setting up the circuit? What could the problem be? The ammeter is the same. Everything is the same. One very small problem, one very small problem might be that the diode is set up in the wrong direction. If he put the diode in the opposite direction this way, it would be wrong. Or if he flipped the terminals of the battery, again, it would be wrong. It would not give a reading. Okay, it has to do with the diode. Diode is in the opposite direction. Okay, in the opposite direction. Name a single device that can be used to control the current. What is the device that can be used to control the current? A variable resistor. Can I draw a variable resistor? Yes, with an arrow in the middle. Okay. يلا. Student investigates the deviation of a ray light passing through a transparent block, and then he measures the refractive index. He is measuring the refractive index. Let's draw. Let's draw. On figure 3.1, draw normal at point E. Extend the normal above AB and below CD. I'll extend the normal above AB and below CD. This is my normal. Okay, above AB and below CD. Name the normal. Huh. Where's the label the upper point N and the lower point M. Okay, this is the first. The upper point N and the lower point M. It's usually NL, normal line, but this time he wants NM. Fine. Fine with me, I don't care. It's NM. And the point which crosses CD with the letter G. The point which crosses CD, this point would be G. Okay, fine. Measure the angle theta between lines FE and EN. Can I find the angle theta? Can I find this angle theta? Yes, I can find the angle theta. Angle theta would be 60. Would be 60 degrees. So this is the angle theta. Soon positions the illuminated silt. Okay, on figure 3.1, extend line FE until it meets the right hand edge of the ray trace sheet. Where's line FE? This is line FE. Can I continue the line until it meets all this point? Okay. Using a ruler, draw a straight line all the way until it meets this edge. So that's it. That's all I need to do. Should I care why? No, I shouldn't care why. Just do as he says. And then label the end of this line Z. Okay, I'll label the end of this line Z. This is point Z. And draw a straight line through the two crosses to meet side CD of the block. Okay, I'll draw a straight line between these two crosses. And I need to label the point CD H. Okay, so this point where it meets CD. I'll label this point H. This point is Z. Let me draw Z closer to this point. And then, what should I do? Label the other end of the line with J. Okay, this other end of the line was J. Okay, no problem. Draw a straight line from E to H. Again, no problem with me. Can I draw a straight line from E to H? Definitely, it needs to be a lot more straighter. Using your ruler from E to H, this is the straight line. Whatever. You're using thin lines, okay? Make sure that your pencils are sharpened. Please make sure that your pencils are sharpened. Do not use thick pencils. This is a very common error. Can I measure the length of EH? Yes, I can measure the length of EH using my ruler. The length of EH should be around 7.5. I know that if you have the paper printed out, it might be a little shorter than 7.5. Measure the perpendicular distance between D, okay? Perpendicular distance D between light HJ and FZ. HJ, where's HJ? This is HJ, and FZ. So we need to measure this distance. Can you measure this distance? This very small distance. Do not draw it. Do not draw this dotted line. Can I measure this line? Can you measure this perpendicular line? Yes, between HJ and yeah, I can draw this. What would it be? Again, it would be around 3 centimeters. It would be around 3 centimeters. You can maybe slightly greater or slightly smaller than 3 centimeters. Can I find d over L? d over L, 3 over 7.5. 3 over 7.5, which is 0.4. This is, and it's unitless, does not have a unit. 0.4. The measurement of the quantity is reproducible if a similar result is obtained when the measurement is repeated by a different method or under different conditions. So just how the student can adapt this experiment to check if the value d over L is reproducible. Again, how can he repeat the experiment? Can I repeat the experiment? Yes, I can repeat the experiment. But I need to repeat with what? Different values of the initial angle. So the initial angle, what was the initial angle? It was 60, I guess. Yeah, it was 60. Theta. Remember this angle, theta between FE and the normal line, it was 60 degrees. So all I need to do is what? Repeat the angle, repeat the process with different values of theta. Can I give him some values for this theta? Yes. Oh, actually, it doesn't need any values, but repeat with, I'll just need to say repeat with different values of theta, which was 60 degrees. So instead of 60 degrees, we can write down 20 degrees, 30 degrees, 40, 50, 70, different values of theta. So just one source of inaccuracy. One very common source of inaccuracy is the thickness of the lines. Okay, or thickness of the rays, the source of the rays itself. Okay, measure the length of GH. Can I measure the length of GH? Where is GH? Yes, I can measure the distance, this small distance. Okay, can you see GH? Can I measure this distance? Yes, I can. It would be around 4.3. 4.3. Now, can I find the refractive index? Can I find n? Yes, 0.866 times small l over capital L. Okay, 0.866 times 7.5 over 4.3. What is 0.866 times 7.5 over 4.3? This is 1.51. So the refractive index is 1.51. Again, without a unit. Okay, without a unit. A student sets up a flexible track at the edge of a bench. Okay, the student investigates a metal ball as it rolls down. Plan an experiment to investigate how one of these variables, okay, whatever variable, okay, whatever variable can affect the size of the distance traveled of the horizontal distance. Okay, we need to find one variable. Can I change whatever variable I need? Yes, I can change because you have a selection of metal balls. You have a selection of metal balls. So, for example, I'd like to change the mass of the ball. Okay, can I change the mass of the ball? Yes, I can change the mass of the ball. Yes. So, for example, this is the variable that I will be changing the mass of the ball. So the range of values, you have to write down, for example, the range of the values. The independent variable is the, okay, range of values, the independent variable, the independent, okay, variable. What is the independent variable? The independent variable, it is the mass of the ball. And we need to give different masses of the ball. For example, we can talk about 10 grams, 20 grams, 30, 40 grams, and 50 grams. So this is the range of the variable. This is the thing that you would be changing. So this is the variable that you are investigating. Okay, key variables, additional apparatuses, table, as we are quite used to. Okay. What is the controlled variable? What are some of the controlled variables? Okay, controlled variables. For example, we need to have the same material of the ball. Same material of the ball. Same position, okay, from which the ball starts. Same position, okay, from which the ball starts. Which the ball is released. You have to leave the ball from the same position each time. Okay? Now, can I state the apparatuses needed? Okay, what are the apparatuses needed? The missing apparatuses. To measure the mass, you need a balance. To measure the distance traveled, you need a what? A ruler. To measure the mass, you need a balance. To measure the distance traveled, you need a ruler or a meter. So these are the apparatuses. We don't need to talk about any safety precautions. You're not required to, or don't need to talk about any safety precautions. Let's talk about the method, the steps. We wrote down the apparatuses. We wrote down the key variables. Let's write down the steps. What are the steps? What should we do? Release the ball, okay? And measure the distance traveled, the horizontal distance traveled. Then repeat and take action. That's it. Release the ball, okay, from a fixed position. Release the balls, all of them, from a fixed position. Measure the horizontal distance, okay, using a ruler. Using a ruler. Okay, that's it. And then what should you do? Then what should you do? That's all. You can say repeat and take average. Anyway, we will say repeat and take average in the conclusion. Can I draw a table? Yes, I can draw the table with the independent variable and the dependent variable. So with the independent variable, we have the mass of the ball in grams. We have the mass in grams, and we have the distance in centimeters. The mass in grams and the distance in centimeters. Okay, so this is the table we need. And then last but not least, can I explain how I reached the conclusion? How can I reach a conclusion? So conclusion for each mass of the ball. Repeat and take average. Repeat several times. And take average. Okay, repeat and take average. Then what should you do? Record the readings in the table. Record the readings in the table. When you record the readings in the table, you can compare the results of the masses of the mass versus the distance using a graph. Okay, and that's all.